Okay, we are covering Newton's laws. That's a picture of Newton with the apple falling. That's supposedly how he came up with his law of universal gravitation. Okay, Newton's first law, also called the law of inertia. And first of all, what is inertia? It's the tendency of an object to resist a change in motion. So we have three parts to that. An object at rest stays at rest, kind of like this couch potato is going to stay at rest. Object in motion stays in motion. And the third part is unless acted upon by an outside unbalanced force. An unbalanced force basically means a force that's going to cause some sort of acceleration. And the motion staying in motion also means that it's going to maintain its velocity. So it's not only going to maintain speed, but it'll maintain direction as well. So how do we see this in our daily lives? It's kind of like if you turn quickly while driving, you might lean to the side. If you stop fast in your car, you're going to keep going forward. If you perhaps are skateboarding and happen to hit a rock and your skateboard stops really fast, you will keep going forward. So those are kind of some examples of that. We also have these little animations here. The truck changes motion because of the outside force of the car, but the ladder keeps moving because of its inertia, its tendency to keep moving. Okay, so to keep that from happening, you would have to provide some sort of force on the ladder to keep it in place on the truck. Okay, here's another animation. The passenger keeps moving forward because the force acts on the car only. What force would we want to have in our car to keep us in the car in case of a car accident? Okay, inertia gives a good reason to wear seatbelts and helmets. Here's the last animation. So we have this guy riding his motorcycle and he hits a wall and he keeps moving forward because of his inertia. Newton's second law states that two things affect how an object accelerates. One is its mass, and two is the force applied. Okay, and it basically states that the unbalanced force of an object equals the object's mass times acceleration caused by the force. So as the mass goes up, acceleration will go down. As force goes up, acceleration will also go up. So that means if we have like 5 people pushing a car versus 1 person pushing a car, the 5 people will cause more acceleration because they have more force. That also means that with the same forces applied, a smaller car will accelerate faster than, say, a large truck. We have the equation net force equals mass times acceleration. We measure force in newtons, mass is in kilograms, and acceleration is in meters per second per second. You might be wondering, where do we get that meter per second per second? That's because it's just showing that for every second, it's going to go a meter per second faster. The net force also means the sum of the forces. You must calculate the sum of the forces, and the best way to do this is by drawing a diagram. Force has both magnitude and direction. So if they're in the same direction, you would add. Opposite directions, you would subtract. Newton's second law can also be related to weight. Weight is mass times gravity. So basically how that works, it's just like F equals m times a, only this time g is our specific acceleration. And weight on Earth has the gravitational acceleration of 9.8 meters per second per second. Now you might be wondering, what is the difference between mass and weight? Well, mass is the amount of matter in an object, and mass isn't going to change due to location, whereas weight is the gravitational force acting on an object, and it can change due to location. For example, you're going to weigh more on Earth than you do on the moon because the moon has a lower gravitational acceleration. Okay. We will be completing these problems later. And then Newton's third law is the last law we're going to talk about. It's the law of action and reaction. For every action, there is an equal and opposite reaction. Okay, so it has to be equal in size, opposite in direction. And they act on two different objects. That's how it keeps the object from not, or keeps the object from having a net force of 0. So an example of this is going to be the recoil on a gun. Okay, you have the action force of the bullet coming out of the gun, and then the reaction force of the gun having the recoil. You might ask yourself, why does the gun not accelerate as fast as the bullet? Okay, and that'll be a question you need to answer. Also, another example of Newton's third law is jumping. You put a force on the ground that is bigger than your weight, and the ground puts that same force back up on you, and you're allowed to jump that way. Okay, and that's it for Newton's third law. You guys will be working on your projects for the rest of the day.